All right, so welcome to this class. This is our very first class in chemistry where we are going to be looking at conversions of units. So in this class, we are going to follow this roadmap here, okay? We are first of all going to define what measurements are, and then we are going to look at the fundamental units of measurements. So we have 7 of them, and then we are going to review the metric system, okay? And then after that, we are going to be using this metric system here to convert units, okay, from one form to the other. So if, for example, you have been given some units in kilometers, you can convert them to meters using the what? The metric system, okay? And then the other part of using unit conversions is what we call as the uh, converting by dimensional analysis. Okay, so we're going to do that part later on. But today, I want us to focus on the conversions using the what? The metric system. All right, so let's start by defining what a measurement is. So I'll go to the next page here. So by definition, okay, we say that a measurement is, okay, a quantitative observation. Okay, it's a quantitative observation consisting, or that consists, okay, consisting of a number, okay, and a unit. So this here is very important, okay? For something to be called a measurement, then that expression should have a number and a unit. So for example, 10 kgs, okay? We see that we have a number and then we have a unit. So we can call this as a measurement, okay? Let's say maybe 20 kilometers, okay? 20 kilometers as the number there, and you can see the units there, okay? Or I can say maybe 0.2500 moles. So here you see that we have a number and a unit, okay? So as long as that expression has a number and a unit, we can call that expression as a what? A measurement. So, for example, let me write this number and then I ask you, let me write this expression and then I ask you if it's a measurement or not. So if I write 10 pens, is this a measurement or it's not a measurement? Anyone?
It's not a measurement.
Okay, why is it not a measurement?
It only consists of a number, but not a unit.
Exactly. Okay, so those pens there, the pens, they are not units. Okay, so we're going to say that there is not a measurement. Okay, so that was just an expression that was obtained by counting. You just counted 10 pens and then you are saying 10 pens. So that is not a measurement. Okay, so we've defined what a measurement is. Okay, and then we are going to move on to talk about the fundamental units of these measurements that we are talking about. Okay, so we have 7 of them, and then from the 7, we are going to get hundreds of units. Okay, whatever unit that you can think of in this world, we get it from the 7 fundamental what? Units. So on my next page here, I have this table that you can see. Okay, so this table here has the 7 fundamental units. Okay, so these units have a quantity that they measure. Okay, so the first unit that you must know is the second. Okay, so we know that the second measures what? Time. And its symbol is just a small letter s there. And then we have the unit meter. Okay, so the meter measures what? Length or distance. Okay, the meter measures length or distance. And then its symbol for this meter is just a smaller letter m. And then we also have mass. Okay, so mass is measured by the unit kilogram, and we can change this kilogram to grams, to milligrams, micrograms, centigrams, a lot of them. We can change them to different types of multiples and submultiples. Okay. The other units that we have is what we call as the ampere. Okay. So the ampere measures electric current. So we are going to be looking at these amperes when you go deep into your NS foundation. Okay, when you start looking at electricity or electrochemistry, okay, that's when you're going to be talking about these amperes. And then the other one that we have is Kelvin. Okay, so Kelvin measures what we call as the thermodynamic temperature. So I know that for you guys, you are mostly used that when we talk about temperature, then we use the degrees Celsius, right? Okay, so the degrees Celsius are not a fundamental unit of temperature. The fundamental units of temperature are the kelvins, okay? But using the conversions, we are going to see that we can actually change a certain temperature that has been given in kelvins, we can change it to degrees Celsius, okay? And then the most important unit, okay, when I talk about chemistry is the mole, okay? Everything that you're going to be doing in chemistry, as long as it's chemistry, okay, the mole is going to be involved. So you really have to know how to use the moles. Okay, if you can't use the moles in chemistry, then there'll be nothing that you'll be doing in this course. Okay, you need to understand and know the mole. So the mole measures what we call as the amount of substance. Okay, so how much of something that we have, we measure it in what we call as moles. And then the last one is the candela. So you are not going to be talking about the candela, you guys, unless you are majoring into a course that deals with a lot of physics and chemistry, okay, and then you start learning optics like that, okay. That's when you can do with a candidate. But in first year, you're not going to be talking about any candidate for you guys. So these are the 7 base units that we have. So from this base unit, we can come up with all the other units that you can think of. Okay, for example, the Newton, the joules, okay, the Pascal, all these units here, they come from the what? From these fundamental units. So we know that pressure is measured in pascals, right? So pressure is equals to force over, is it force over area? Or area over force? Should be force over area, okay? So the area is measured in meters squared, and then this force should be measured in Newton, okay? So the units for this pressure will just be Newton per squared meter, like that. So this squared meter here comes from the what? The basic units. So any other units that you can think of comes from these fundamental 7, okay? All right, so I've talked about the basic fundamental units. Okay, so these basic fundamental units, okay, for example, you can be given this unit. Let me just clean this up. So you can be given 10 kg, okay, and then you are asked, change this 10 kg to grams, okay, or change it to maybe uh, decigrams, like that, okay. So how can we be changing from one form of the units to the other? Okay, so we change these units from one form to the other by using what we call as the metric system. Okay, so the metric system is simply a table that contains multiples and submultiples of 10. So on the next page here, let me go on the next page. I have this table. I'm sure you've seen it somewhere. Okay, so this is what we call as the metric system or the metric table. Okay, so for us to convert all those units, we need to know how to use this metric system. If you don't know how to use the metric system, I can assure you, you won't be able to convert any units from one form to the other. Okay, unless you just know the specific conversion factor for those units, you'll be able to convert. Okay, so this metric system, I said it has multiples and submultiples of what? 10. So you can see in this first column here, it's written factor. And then we have 10 to the power different numbers that we can see here. Okay, so all these powers here, you can see that they are negative. Okay, so if a power on this 10 is negative, we call that as a submultiple. Okay, no wonder here I have these submultiples. And then if the power is positive on that 10, like in this column here, we call that as a multiple of what? Of 10. Okay, so multiples and submultiples of 10. That's the metric system. So this metric system consists of one, the factor, the prefix, and the symbol. Okay, so the factor here indicates the numerical value for that specific prefix, and then the symbol just represents that prefix. So for example, if you talk about deci, okay, deci has the symbol small letter d, and its value is 10 to the power minus 1. Okay, so in whatever units that you can be given, if you are given maybe 5 decimeters like that, just know that this deci here okay, represents 10 to the power what? Minus 1. Okay, maybe I should give an example of something that is common to you. Let's say 2 kgs of sugar. Okay, so this K here is what we call as the kilo when I come there. Okay, the K there indicates the prefix kilo. Okay, and its numerical value is just what? 10 to the power 3. So wherever you see a kilo, just know that that is 10 to the power what? 3. Okay, and then I can even give an example which is more common to you guys because I know you guys are always on Facebook. Okay, so on Facebook there, when someone posts something, okay, on that like button, you sometimes see like maybe they write 10K. Okay, so it means that 10 multiplied by the value of the K, people have liked that post. Okay, so if the post has 10K likes, it means it has 10 multiplied by, we said this K has a value of what? 10 to the power 3. So this 10 to the power 3 is the same as 1,000 like that. So 10 multiplied by 1,000 here is going to give you 10,000. So when you see 10K on that post on Facebook, just know that, okay, this person has gotten what? 10,000 likes. Okay. Sometimes on these big pages, you see maybe 1M. So this 1M here indicates 1 million likes. Okay. So the million, where is it on this metric table? It's here. Okay. Just below the kilo there, you can see the million there. So this one here. Okay. So whenever you see a capital letter M, okay, capital letter M, it means mega. And that mega has a value of what? 10 to the power 6. Okay. So you need to get familiar with the metric system for you to be able to convert units from one form to the other. Okay. So we have a lot of them here, but for you guys, you are just going to focus on the following. So let me circle the ones that you are going to focus on, okay, at your level. So at your level, you're going to focus on, when we talk about the submultiples, you're going to end at pico, okay? So like that. So these ones here, going up like that, those are the prefixes that you should know and their values, okay? And their symbols as well. And then when you come to the multiples, you just end on, uh, okay, they can go up to penta, I think. So you go up to penta there and then you go up here. So these ones on top here and these ones are the ones that you are going to be what? Dealing with. Okay. These ones below there, just forget about them. They don't come. Okay. Unless otherwise. All right. So you need to know that when they say deci, it's just 10 to the power minus 1. Centi is 10 to the power minus 2. Milli is 10 to the power minus 3. Micro is 10 to the power minus what? 6. So most students confuse the micro and the milli. So notice that the milli is represented by a small letter m. And then the micro is represented by this symbol that looks like a U. So this one is called a mu. Okay, this symbol is called a mu. So don't make the mistake of confusing a milli and a micro. A milli is small letter m, a micro is mu. Okay, this symbol that looks like a U like that. Okay, don't confuse them. So the micro has the value of what? 10 to the power minus 6, milli 10 to the power minus 3. All right, so you need to familiarize yourself with all these. The pico, it means 10 to the power minus 12. The nano, 10 to the power minus 9. And then when you come to the multiples here, we have deca, which is just 10 to the power 1. Okay. And then hecto, which is just 10 to the power 2. Just like that. Kilo, 10 to the power 3. Mega, 10 to the power 6. Giga. Okay. So this giga is what you see in your storage devices, like maybe it's 2 GB. Okay, so this G here indicates the what? The giga. And that giga has a value of 10 to the power 9. Okay, so whenever you see G there, capital letter G, just know it's 10 to the power 9. Okay, so once you familiarize yourself with these, it means you can change any units. Okay, you can change any fundamental units to its submultiple or to its what? Multiple. All right, so now let's do some conversions on the units there. Okay, so if you have any questions on whatever I've explained, you can ask. Any questions there? All right, no question. So it means we can now talk about how to convert these units. Okay, we can talk about how to convert units. So I said we have two types or two ways in which we can convert units. The first one is the direct method.
I can go first.
Okay, someone has a question?
Miss, yeah, I have a question.
All right, you can ask.
So, how are you finding it first?
How am I finding what?
This is when I've started this group.
This is when you've joined the meeting.
Yeah,
Okay,
but
so
you should not.
okay, so here we are offering lessons. These are online lessons. Okay, so like the lesson started some few minutes back, some few minutes back. Okay, so if you missed the beginning, don't worry. I'm going to share the recording so that you can watch it and understand from the very beginning. Okay.
Oh,
Yes.
okay.
All right. So I was saying we have two methods in which we can convert units. The first one is the direct method where we use the metric system. Okay. And then the other one is what we call as dimensional. Okay. Dimensional analysis. So in this dimensional analysis, we need to use the conversion factors. Okay. But I'm not going to talk about dimensional analysis today. I'll just use the direct method where we're using the metric system here. Okay. So in dimensional analysis, you are given two units in one expression. So for example, density is measured in what? Okay, so someone is writing on my screen now. Caputo. Okay, you also want to teach. So like density, okay, the unit we are saying maybe 10 grams per what? Cubic centimeters like that. So if you in your question, okay, you have two units like that, we always use dimension analysis to convert, okay? And then in the direct method one, we just have one unit, and then we are also converting to one unit. So we can convert, if you want to convert these grams per cubic meters to maybe kgs per cubic meters like that, we use dimensional analysis because we have two different units in this one expression. Okay. And then when we have one unit, just like if we have 10 kgs, and then we want to convert it to grams there. Okay. Here, we're just going to use the direct method, which is what's the metric system. So in this video, we are going to focus on the direct method, And then in another video, we're going to do the one for dimensional analysis. Okay, so let's get some units here, and then we try to convert them. Okay, let's get some units, and then we try to convert them. Okay, so let me erase what this one wrote here. All right, so our first question, we are just going to convert, okay, 10 centimeters to meters. Okay, so how can we convert 10 centimeters to meters using the metric system? Okay, not using the normal way that you are used back at secondary school, but using the metric system. Okay, so when we are converting a unit, okay, from one unit to the other, what we need to know is just know the prefix that we have there and the prefix that we have here. Okay, so here the prefix that we have on this first unit here, the 10 centimeters, the prefix that we have there is centi. Okay, and from this table here, we see that the centi is what? 10 to the power minus 2. Okay, and then on the other part there, can we see any prefix there? Okay, can we see any prefix there on the other part? No, we don't. We can't see any prefix because this is just meter. So it means there the prefix will just be 10 to the power 0 because there is no prefix there. Okay, so when converting this 10 centimeters to meters, what we are going to do is we are going to write 10 and then multiplied by, okay, the first prefix that you can see here. Okay, or the prefix that you are coming from. So the prefix where I'm coming from is just what? 10 to the power minus 2. Okay, and then you are going to divide this expression by the prefix of where you are going. Okay, the value of the prefix where you are going. So we are moving from centimeters to meters. So we're going to divide it by what? 10 to the power 0. Since these meters here do not have a what? A prefix. Okay, so I'm going to say 10 to the power 0 like that. And then once I reach here, okay, I can group these 10 to the power somethings together, and then this one alone there. So I'm going to say 10 multiplied by 10 to the power minus 2 divided by 10 to the power 0. So we know that 10 to the power 0 is just 1, okay? But for the sake of unit conversions, I'm not going to use that. I'm going to say this is the same as 10 multiplied by 10. Since here we have the same bases that are dividing, okay, 10 and 10, we need to subtract their powers. So it will be minus 2 minus 0, which will just still give us what? 10 times 10 to the power minus 2. And then these here, now these units here will just be in what? Meters. Okay, so we have converted from these centimeters to meters using the metric what? System. Okay, so you don't leave your answer like this. You always have to take it to scientific notation. Okay, so when taking something to scientific notation, you have to make sure that the value that you have there is 1 greater than 1. Okay, and then it's less than 10. So this 10 here is greater than 10. So it means we have to make this to be less than 10. So what are we going to do? So whenever you see a number without a decimal place like that, or like 5, maybe 56, it means the decimal place is just there, there, and there. So it means for this number, okay, the decimal place is there. So you need to move this decimal place one step to the what? To the right. All right. So once you move this decimal place to the right, okay, what are you going to get? We're going to get 1.0 times 10, okay? And then I moved, how many times did I move this point to the left? Okay, I moved it 1 time. So if you moved your decimal place to the left like that, it means you're going to multiply by 10 and say 10 to the power how many times you've moved, okay, or the number of times you've moved to the left. So if you've moved to the left, it means your power there is going to be a positive power. If you've moved to the right, your power should be a negative. So I've moved 1 time to the left like that. So I'm going to say this is power 1. And then I still have this 10 to the power minus 2 like that, and then meters. Okay, so we can now combine this 10 and that 10. Okay, since they are the same bases and we are multiplying here, our final answer will just be 1.0 times 10 to the power, and then we add the 1 and minus 2, which will just give me minus 1 meters. Okay, so this 10 centimeters is the same as 1.0 times 10 to the power minus 1 meters. Okay, so any questions there on how we've converted this unit here before we look at other examples? Okay, no question. All right, let's look at another example.
Sorry,
Oh, okay.
not to take you back.
Yes.
Yes. Here where you wrote 10 times 10 to the power negative 2 over 10 to the power 0. I didn't understand what you said there.
Okay, so I said here, since you have the
Yes.
same bases, this is 10 and this is 10, okay? So this 10 is power 0, this 10 is power minus 2. So we can combine these by what we call as the laws of indices, okay? So since the base is the same and we are dividing this expression, to write it as one expression, we're just going to say 10 to the power 2, and then we subtract the power that is below there, which is minus 0. So that's what I did there. Is it okay? The one who's asking?
Yes, thank you.
All right, so let's look at more examples for you to understand the concept so that it should sink in, right? Okay. So I'm going to have this expression here. So 676 centimeters to kilometers. So let's convert this 676 centimeters to kilometers. So the first thing is you have to know the value of the prefix. Okay. So here we have the prefix centi. There we have the prefix what? Kilo. So centi from this table is just 10 to the power minus 2. And then kilo is what? 10 to the power 3. Okay. So we said we write first of all the number that we have, and then we say times the value of the prefix that we are coming from, which is just what? 10 to the power minus 2. And then we're going to say this divided by the value of the prefix where we are going. So where we are going, we have 10 to the power what? 3. So 10 to the power 3, I'm going to divide it there like that. Okay, so there it means we are going to have 676 times 10 to the power minus 2 divided by 10 to the power 3 like this. So this here, we are going to use the same trick that we used on the previous question. We are going to say this is the same as 676 multiplied by, since the bases are the same and we are dividing here, we are going to say this is the same as 10 minus 2 and then minus this one which is in the denominator, which is just 3. So there we are going to have 676 times 10 to the power minus what? 5. So this here will be our value in what? Meters. So if you want, you can leave your answer in this form, okay? But most of your lecturers and tutors will require you to leave this answer in standard form. So in standard form, I said you have to change this number into a scientific notation. So scientific notation, it means this number that is there, okay, should be greater than 1, but should be what? Less than 10. Okay, greater than 1, but less than 10. So if you are given a number like 676 without a decimal place, a decimal point, I mean, it means the point is just there. So you're going to move this point 1, 2, so that this number is now greater than 1 and less than 10. So when we do that, okay, when we do that, it means there we're going to have 6.76 multiplied by 10. So how many times have I moved to the left? I've moved 2 times. Okay, it means the power on the 10 is going to be 2. And then I still have this 10 times I still have this 10 to the power minus 5. So times 10 to the power minus 5 kilometers. Okay, and then from there, since this here and this have the same bases, and here we are now what? Multiplying. So we are going to add their powers. So we are going to say the final answer is just 6.76 times 10 to the power. What is 2 plus minus 5? It will just be minus 3. And then kilometers. Okay, so that 676 centimeters, if we change it to kilometers, it's going to give us that value. Right, so you've seen how easy it is when you just know the metric system there. Okay, let's look at another example if there are no questions here. All right, so let's look at another example. Okay, so another example, we are going to say, let's have 5 3 micrometers, and then we are changing this to nanometers. Okay, so what are we going to do? We first of all have to get the values of this. Here is the micro. Remember, where is it? This one here. This is simple. It's the micro. So what value does it have? 10 to the power minus 6. And then this is the nano. So nano here has 10 to the power minus 9. So 10 to the power minus 9. So to convert these micrometers to nanometers, we are first of all going to write 553 multiplied by the value of the prefix where we're coming from. So the value of the prefix where we're coming from is just 10 to the power minus 6. And then we're going to say divide this whole expression with the value of the prefix where we are going. Okay, so that will be 10 to the power minus 9. So this here, it will mean I have 553 times 10 to the power minus 6 divided by 10 to the power minus what? 9. Okay, so from there we're going to have 553 times 10. Since they are dividing, we can subtract their power, so that will be minus 6 minus 9, like that. So notice that here I've said minus and then I have minus 9 there. Okay, so be careful with the signs there. So it means what we're going to have here is 553 times 10. Okay, and then here it will be minus 6. Minus and minus are going to form a positive 9, like that. So minus 6 and this positive 9, it gives us a what? A positive 3. So I'm going to write 3 there. Right, so these will be in what not? They will be nanometers, like that. But this here is not the standard form. Remember, the standard form, this number should be greater than 1 or less than 10. Okay, so that number there violates whatever we have there. So we need to change it. So I'm going to say 553 times 10 to the power 3 meters. And then let's move the decimal place. Since it doesn't have a decimal place, it means the decimal place is there. So I'll move it to 1, 2, so that this number is greater than 1, but less than 10. So I'm going to have 5.53 times 10 How many times have I moved to the left? 2. So power positive 2 multiplied by 10 to the power 3 nanometers. Okay, so there we have 10 to the power 2, 10 to the power 3. And both of those have positive numbers, so we can just add them. So it will be, the final answer will be 5.53 times 10 to the power 2 plus 3, which is 5 nanometers. So we've converted the micrometers that we had to what? To the nanometers. All right, so any questions there on how we are doing the unit conversions? Any questions there? All right, so if there are no questions, let's look at the last example for this class, okay? And then I can even give you some practice example questions so that you just try out to see if you've understood the concept, okay? So let's convert 517 nanometers to decimeters, okay? So the first thing, always know the value of the prefixes there. So the nano is 10 to the power minus 9. The deci is 10 to the power minus 1. Okay, so what I'm going to do is 517 multiplied by the value of the prefix where I am coming from, which is nano. So 10 to the power minus 9. Then I'm going to divide this whole expression by 10 to the power minus 1. So this is going to give us 517 multiplied by 7. Multiplied by 10 to the power 9 divided by 10 to the power minus 1. So this is going to be 517 multiplied by 10. And then we can subtract those powers. So it will be minus 9 on top, minus the minus 1 down there. So this will be 517 multiplied by 10, okay, to the power, this will be minus 9 plus 1. So that will just be minus 8. Okay, so these will now be in decimeters like that. But we have to express this in standard form. So we move the point that is here, 1, 2. So that will be 5.17 times 10. How many times did we move the point? 2, multiplied by 10 to the power minus 8 decimeters. So the final answer there is just going to be 5.17 times 10 to the power what? What is 8? 2 plus minus 8 there to be minus 6 decimeters. Okay, so that there is our final answer. All right, so I've taught you guys how to convert units using the metric system. Okay, so any questions there? Any questions before I close the class? All right, so if there are no questions, then try out these questions. Let me just write them down. Okay, so try out these questions. So number 1, so you can take a screenshot after I finish writing them. You can convert 5.53 kilometers, convert it to decimeters. 2, convert 817 picograms, convert it to grams. And then 3, let's have, okay, 3, 2.79, 2.74, I mean, megameters. Okay, megameters. Let's convert it to kilometers. Okay, so you can take a screenshot of this and then you try to solve them, and then you can send to my inbox. I'll be able to tell you that, okay, there you made a mistake, there you did the correct thing. All right, so that's it for this class, unless there are any other questions. Okay, so this was just an introductory class, so it was a bit short. I wanted to make it short. Okay, so any questions there, guys?
Sorry, doctor.
Yes?
I don't really have a question, but I just wanted to say thank you very much.
All right, you are welcome. All right, so the lessons will continue. We've started today and we will be with you guys until you write your exams, okay? So our classes, as usual, they are online. like using Zoom, like the way you've seen here. Okay, so we are going to be teaching you, first of all, the topics. We are going to be solving together your tutorial sheets. We are going to be solving together your assignments. We are going to be solving together your past papers. Okay, so the free classes will run for 2 weeks. 2 weeks, the classes are free. Anyone can attend. And then after that, okay, it means you need to subscribe for you to attend the classes. Okay, so the classes, our classes go at 100 kwacha per course per month. So if you register for all the 4 courses, it means you'll be paying a 400 per month. Okay, so be free to interact with us. You can interact with me. You can interact with my other colleagues. So tomorrow you are going to have math. Okay, and you are going to be with tutor Marius. So he's going to introduce himself, and then you are going to learn the first topic, which is I think that's set theory in math, right? Okay, we are going to learn set theory in math. All right, guys. So thank you so much and have a blessed night. I'll upload this video on my YouTube channel so that in case you didn't understand, you can watch it. Okay. So thank you so much and blessed night.